Okay, hi, my name is Simon. I'm a cybersecurity engineer, an active cybersecurity practitioner, a deep researcher when it comes to web. I have a lot of interest in IoT. I do research, I do build IoT devices, and today we're doing something quite different. Today, what we're doing is we are going to do a 3D build, or we are going to do a 3D design of our four motor chassis. So let me give you the context. This site is called printables.com, and onto this site you can see this is something like what we have or something I have. And besides it, let me just bring it here. You can see these are printables. They are 3D. They are drawn to scale. If I say drawn to scale, I mean that the scale that once you download that file, it's the same scale that has been used to design the real one, so you don't need to adjust. So this is what I came up to. I have downloaded this. It's a .stl file. Then this is my inspiration for a soccer board I'm creating. I want to create something like a shovel at the front here. So with my little design, with my little knowledge in designing Blender, that is Blender, I've decided that I'll recreate this. So I've opened my Blender, and maybe just to show you, I have several Blender projects I've been working on. Let me not save that one. Let's just open. I do design interiors. I've been doing it for fun for a while, but I got to a point I'm doing it on a different scale, not just for fun. I'm doing it differently. I don't know. Okay, okay. Supposed to be loading. No problem. This happens quite a time. Okay, it has loaded. It happens. Blender is a very heavy software, and considering that what we're opening is also a very much design thing, it takes some time. Before it loads, let me just come back to the context of what we're doing. So I'm creating something of this sort, that shovel, and I'll place it at the front of my robot. So that will be the one controlling the ball. I was thinking of creating one with servo motors that once it gets the ball, it locks it, but that will be to a disadvantage to my opponents or the people I'll be playing with, because there will be no fairness. It's like playing a football match with a golden boot or with a metallic boot. Nobody will come to defend against you because they fear you might harm them. So it's just I always give Blender time. Blender takes a lot of time. I just wanted to show us what. No, I'm not supposed to close it. I'm not supposed to close it. Okay, wait for the program to respond. I just nearly closed that program. So uh, I was doing this 3D design just for fun for quite a while. I got to a point. I also do something with it's ArchiCAD. I have designs in ArchiCAD. This is the first one, the second one, the third one. I have designs. I tried SketchUp, but I felt SketchUp was a little bit behind, so I think I use ArchiCAD. Okay, there's no behind, but my preference is ArchiCAD actually. Yeah, so this is the design I was talking about. It takes time to load. This was just a simple room with a monitor. Oh, okay. I need to change to this so that it renders with color. Yeah, now these are the things. This is just a little bit in interior design. It's still loading. It does not completed the loading. But you can see, yeah. So not this one. I think, yeah, you can see that I've been doing this for a while, and you can see that maybe at some point I'm almost mastering this designing. Yeah, so this is it. These are how it has a PS5, a monitor, a desktop, and a bed. This is a shower. This is a small cupboard near the bed. This is a table, a carpet. It also rendered some lights. Yeah, yeah. Okay. uh, I felt like designing something for fluids. With fluids. I was considering in my design, but anyway, I'll just put of it. So what we are doing today, I don't want this video to be more than 10 minutes. are still within time. Okay, we are still within time, no problem. Okay, so I'll do this file. Let me just let me do this. Let me close this one. I'll come here and open Blender. So let me open Blender. This is our Blender. And save. Okay. Blender is loading. So to use a software like Blender, maybe you need a GPU. It will work well with a GPU. So my computer has an NVIDIA GPU, a dedicated GPU. So what we'll do, this is our playground today. So I'll come here, file, then I'll import because .stl is not it's not native to Blender, so we import it that file. So it's in my downloads. I'll import it this one, import stl. So this will just help me with the dimensions when I'm designing for motor chassis, and you can see it's drawn to scale. Like what I'll do after this, okay, let me just move it to the center. You can come here. What I'll do, actually after this, I'll just go ahead and print it. So let me duplicate it, and I'll duplicate it with another because it always has 2 layers. So I'll just right click and then I'll duplicate object. Then the scale, it's on the Z axis. So I press Z to ensure that it maintains the Z axis so that it's aligned. It's aligned. I'll assume that space. Oh, my game has finished downloading. I also like game. That space is too much. Ain't it? I think let me just move it. Okay, let me move it a little bit. And nope, that's too. Yeah, somewhere there. So from there, I'll now be designing. Let me join these two so that they act as a single unit. So I've joined them so that if I move them as a single unit. So what I'll do, I want to put that, you see that marker, there's a certain marker, this one. I want to put it directly on the front. I put it here. I want to put it, hope it's not inside. And yeah, somewhere there. So what I'll do, I'm now designing that part, and I'll just be using a cube. So what I'll do, I'll shift a mesh cube. So you see how small that cube is. Then what we'll do is measurements, or our measurements is in millimeters. So I'll just do this. But alternatively, I can just decide to scale. I scale it, Control Z. I want to scale it on the x-axis. So we ensure that the scaling is being done on the x-axis, not here. I'll just ensure it comes a little bit here. Then what I'll do, but probably this video is gonna be low. It's going to be low. Then I also do this to the z-axis, but alternatively you can just take this dimension. So ChatGPT had suggested it to me, but anyways, I'll just use what I can. So let me assume this to 50. It is too big. I think 50 is 5 centimeters. So let me try 35. 35 seems to be big. 32. How about 32? 32. Let's go with 20. Let's try 27. Yeah, I'm also considering, or I'm also putting into mind that no, 27 is small, because once we put it on tire, it moves. Like this chassis has no tires, so I'm also considering the height of the tires. That's 32. 32 making any sense? 32. I'll go with 32. Go with 32. So let me do this. I'll move it here. Let me move it that way. Right. After moving it, yeah. So this is what we'll do. I've moved it here. So on that chassis we have these two holes. So because this is going to be 3D printed, I wanted to create something that does what? I wanted to create this to be a temporal add-on, but I never wanted to have it being screwed onto this chassis. So I'll create an extension that just plugs in here and here. Yeah. So what we are going to do now, this is too flat, right? You can see it's too flat. So we need some extensions to create something like a V. So there are different alternatives to that. I can decide that I just duplicate this. So I can right click, I duplicate the object, pull it here. You'll see how it will come out here. Then I also hold this, I duplicate the object, I pull it here. And this is going to be very basic. I come here. You see there's a misalignment, right? So I'll toggle the z-axis and then I'll touch on this and make sure that it totally aligns here, right? Then I come here, I make sure it totally aligns. Yeah, then I'll pull it to the x-axis. No, cancel. I'll do this. I'll hold it. Okay, it just allows me to push it to the x-axis. Is it? So I want to push it to the x-axis until it touches this. And this one I also want to push it to the x-axis so that there is no overlapping. I'm just preventing the overlapping. But I also don't want a lot of spacing between. Shift, then move. The other one has worked quite well. Then I'll do this. Then now what I'm going to do, I'm going to rotate this at an angle. So there's a rotation. So we are going to rotate it on the x-axis. If I say rotation, I mean no, wait a minute. So there are two ways to rotate this. Control Z, Control Z. Yeah. So there are two ways to rotate this. There's this. I think let me use this one. So we are rotating it. Oh, I've seen where the issue was. We are on the z-axis and I was controlling the x. So this is the z-axis. Yeah, there are two ways to controlling that. You either choose this option, this, or use this here. So I'll use this one here because I want to be correct with the angles on both sides. So I'm rotating it to, I think, this is good. Let me see. 37 is too wide. ChatGPT had suggested 45. So 45, where's 45? Okay, I can just type it, 45. I also come to this one, I rotate to z-axis, I rotate to 45. It's supposed to be positive because, okay, it's the inverse of this. So on this side is positive, on this side is negative. Hope you get that. So then we'll move it. We'll move it. It's just a simple plug and play. It's not that much complicated. We'll also move this one here and then move it here so that it aligns. Yeah, I'll just try. I know it's probably it's not that much accurate. Yeah, you can see that. Let me push it now to this angle so that I move it down here a little bit. Yeah, and also I pull it up here. No, is it okay? You know what is interfering there, so that it aligns. So right now, this is like a shovel. Uh, I don't know, but probably I'll have to adjust that angle. But no need to adjust the angle. What we'll do is now we'll rescale, we reduce the scale, uh, so that it appears as an arm. So this one was this 8 centimeters. No, is it 8 centimeters? Where is it? 8 meters. It's not supposed to be in meters. Just a little bit. It's not supposed to be in meters. It will give us a very different thing. No. Wait a minute. Okay, let's do this. I think I changed it to millimeters. Okay. Yeah. Okay. No problem with that. Since we are using this as we're using the real chassis as the what? As the reference, I think it will just be good to go. So what I'm going to do here is I'm just going to reduce this size. So what is it the X? Yeah, I'm going to reduce it to that point. Marking the scale, like whatever I do here, I'll do on the other side. So actually what I can do, I can just let me try with 50. This one was the X of this one is 79, so 50. Let's lower it to 45. Yeah, 45 will do. And also on this side, going to lower the X to 45. No, wait a minute. Okay, 45. No. That's the thickness. The thickness will maintain at 1. So here should be 45. Oh no. It's the X scale. I'm forgetting it's the X scale 45. Yeah, so that we have something like this. So let's move it. First I'll move it to the y-axis. We've inverted, we are on the x-axis, so the y-axis goes above. The x-axis goes somewhere here. This is just rough work. This is just rough work. And if this video becomes too long, I'll do it in, I'll just do make it 2 videos. Yeah, so this is my approach to that. This angle feels too big, but we'll go with that. So I say that we have these 2 holes. You see these 2 holes. I want this system to just be a plug and play. So I'll move this point. This, I don't know how it's called. I'll move it. Where is it? Is it moved by? No. Yeah, I've moved it there. So let me go back to the z-axis here. So I'll add a plane. So shift D. Okay, where is it? Shift D. Shift A. I'll add a plane. A plane is just a small structure. With that, I'll transform it. So let me transform it to the. Okay, I know why I'm struggling, and I have So let me make it, let's see, 20. Yeah, 20 works. So 20 here, and on the other side, that's the y-axis. I'll give it 7. This is 7. 7 is small. Okay, don't know what. This will take the 20. Alright, this one let me try with 15 and see. 15. And we'll rescale it to this. No, Control Z. Okay. Then we'll move it. So let's move it this way. This is just rough work. This requires a little bit of time to ensure that it fits. Add some thickness. So add some thickness. Let me try something like 4 or even 5. It's looking so small. Okay, I think that's still small. Let me add some thickness. Let me just try with 10. It's not responding to that. No. This. Okay, transform. Let me do it on the y-axis. Let me try. And if I 10 can do, I just want it to be a little thicker than what. I don't know what is happening. This video is already beyond the time. Okay, and we'll duplicate this. So we just right click, duplicate object. Then because I want to maintain the scale, I'm maintaining it on the x-axis, and I also move it here, somewhere here. So I think I'm done with what I'm doing. When it's finished, I'll just screw it here. Maybe what I can do is, okay, now let me join this. Let me join this and this and this. So let me join them. To make them a single unit, I've joined them. So let me move them. Let me raise them a little bit. Just a little bit, because that ball is quite big. It's not that small. There, so that the joints are made there. Then let me ensure that this one moves into somewhere, not that much, but it somehow aligns with that, right? And this one also to get but not protrude. Yeah, so this is the shovel we'll be using for our 4-chassis motor system, and these two can just be deleted. So it was helping us to build on scale. So I'll take all, then I'll join. No, I'll just do this, then shift this and this. I hope it's not floating. Okay, then right click, I join. Now this is a whole unit. You can see I can now move it the whole unit. You see. So what I'll do, file, export. Now I'll export also as an STL file, a .stl on my desktop. Shall I create a new folder? Let me create a new folder and call it the shovel 3D, and export STL. Yeah, and that's how have 3D designed my model and show you the process of printing it.